Hello and welcome back to my YouTube channel, Hanson Math. Let's get right into it. Today's lesson is a cursory approach to the law of cosines. So here we go. Warm up here says solve the triangle. So I'm going to arbitrarily mark the three vertices A, B, C. Angle A is 30 degrees. Side B is 10. And side C is 15. That's all we know. What if I ask you to solve the triangle? Meaning that you tell me the length of little a, and you tell me the angle measure of capital B, and you tell me the angle measure of capital C, what would you do? Well, we can't do regular sine, cosine, or tangent because I have no evidence of a 90-degree angle. We could try law of sines that we've learned previously. So I could say, if I grab this side, I could say 15 compares to the sine of, oh no, I don't know, it's opposite angle C. Okay, scratch that. Well, I could start with 10 here. I could say 10 compares to the sine of its opposite angle, which is, oh no, it's unknown, it's B. That's not going to work. Oh, holy smokes. The law of sine doesn't work here. Why doesn't it work? Well, to get to the bottom of this, it doesn't work because you were not given from the outset a side angle pairing. And what I mean by that is to kick off the law of sines, you'd have to know an angle such as angle A and the side measure across from it. If you do not have an angle side ratio given like that, you cannot use law of sines. So, oh, scratch, what are we going to do here? There has to be another option. We need another strategy. That strategy, my friends, is going to be the law of cosines. Law of cosines is useful when your triangle gives you from the start a side, an included angle, and a side, or all three side measures and nothing, no information on the angles. So here are the formulas, okay? Just depending on how you want to think about which side and angle is A, B, and C. So there's three different varieties, and same thing with this alternative form. You don't need to memorize this. It's just here for reference if you'd like. Let's get into a couple of specific examples, and I'll show you exactly how law of cosines works in action. Let's jump right into example 1 here, and you will see that we have a triangle, and we were given the following. We were given a side, an angle, and a side. So if you look at it and kind of swoop around, it spells out side, angle, side. When you're given a side, an included angle in the middle, and then another side, kind of like a side angle side sandwich, that is the perfect opportunity to use the law of cosines, which formula is given right here. Starting with a squared, which is the unknown side. So let's diagram this a little bit, and then what we're going to do here is we're going to find the remaining two angles and the remaining unknown side so that the whole triangle will be solved, if you will. So here we have angle A right here. Across from it is side A, lowercase a. This is exactly how we diagram the triangles in the law of sines video. We have angle B right here, and across from angle B would be side B. That was provided, that was 26 centimeters. And then across from angle C, opposite angle C, is side C, lowercase c, which is 24 centimeters. So again, this is exactly how we diagrammed it in the lesson on law of sines, okay? Once you have everything diagrammed like this, you can start plug and chug into the formula, which works like the following. A squared will help us find A, which is this unknown side right here. So we don't know it, as you can see at the moment, so that is going to remain a squared. B squared is this side here. So that's going to be, well, B is the side, so the length is 26, and the formula says to square it, plus C squared, side C is this one. So that's 24 centimeters. So it's 24 centimeters squared minus 2 times B, which again is 26, times C, which again is 24, times the cosine of angle A. Angle A was provided, it is 134 degrees. Now, speaking of degrees, when you go into your calculator under mode, the mode has to be in degrees. If it's not in degrees, you will get these wrong because we are in degrees, as you can see with the symbol right there. Okay, so what I would suggest to you now is if your calculator is in degree mode, you're going to punch this in all in one fell swoop. So you're going to take your calculator, and I'm grabbing mine, you might hear the buttons clicking, and I'm going to press 26 squared plus 24 squared. You should do this with me to ensure you get the right calculation. Minus 2 times 26 times 24 times cosine 134, enter, and I get 2,118.9. I'm going to choose to round to the 10th place, and that's a squared. I don't want a squared, I want just a, so I'm going to have to take the square root of both sides. So I'm going to go square root, a equals, I'm going to take the square root of 2,118.9, and we get 46.03, which is 46. Okay, if you want to put in your unit centimeters, that is perfect. And I'm going to put it into the picture in just a minute, but I want to point something out here. You don't have to so much worry about these A's, B's, and C's, okay? So A squared is the side opposite. A is the side opposite of the angle given, okay? B and C are the adjacent sides to that angle. You see how they're on both sides of my 134. B and C are the adjacent sides. And cosine capital A is that included angle, okay? So again, B and C are your adjacent sides, and little a is the opposite one across. So the more you do these, I think you'll see how it flows, and you don't need to really worry so much about the letters A, B, and C. Be that as it may, we have 46. So I'm going to put that into the picture. Let me clean this up a little bit. Okay, so we know now that side A is 46. So I'm going to put A, oh, my bad. I'm going to put A is equal to 46. So now all of our sides are known. We know A is 46, C is 24, B is 26. Now we just have to find the remaining two angles. Now that we found that side A has a length of 46, you'll notice that we have a angle side pair where they're both known. Angle A is 134 degrees and its opposite side, little a, is 46 centimeters. Once you have that pairing, it's actually much more efficient to use the law of sines. So now we will use the law of sines, which we learned in the last unit. So that works as follows. We take this A length of 46 and we compare it to the sine of its opposite angle, capital A, which is 134 degrees. Now we set that equal to a ratio of another angle, another side, excuse me, compared to its opposite angle. So how about we grab B here, which is 26, so that's 26 over the sine of its opposite angle, which is capital B over here, which is unknown, so we must leave it as capital B. Next step, cross multiply. So we have 46 times sine B equals the other cross product, 26 times sine 134. We want to find out what angle B is. It's attached to the sine function, so we have to divide out the 46. Whatever we do to one side, you must do to the other. So at this point, the 46's cancel here, which leave us with sine B equals, and on side 2 of the equation, we have this expression right here, which we need to evaluate. So I'm going to grab my calculator. I'm sure that I'm in degree mode, and I'm going to press 26 times sine 134, enter, divided by 46. And I get point, let me change colors here so you can see it better. I get 0.4066. Now, the more decimal places you use, the more accurate you will be. So finally, since sine of angle B equals this, to get angle B by itself, you have to take the inverse sine, which you get by hitting the second key on your calculator, inverse sine of 0.4066. And if you do that, which I will do right now, second sine 0.4066, I get 23.99, which rounds to 24 beautiful degrees. Okay, so now I'm going to pop that information into the picture. I'm going to get rid of some of these arrows and stuff that's cluttering it up. So now we have, switch to my pen, put it in the picture. Angle capital B is 24 degrees. So 24 goes right here. So now I notice the only thing that's missing, ladies and gentlemen, is angle C. But if you know two out of the three angles of any triangle, that's simple. You just use the triangle angle sum, which is 180, minus what you have, 24 degrees for angle B, minus 134 degrees for angle A. And doing the arithmetic here, I've got 180 minus 24 minus 134, which is 22. So angle C is 22 degrees, and this triangle is fully solved. We know all three angles, and we know all three sides. Boom, 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 boom. That's the goal. All right, we have one more example to go through, and we will wrap this video up for today. Okay, finally, in example 2 here, you'll notice that the scenario we're given is a little bit different. We are giving an 11-kilometer side, a 10-kilometer side, and a 17-kilometer side. So we've been given side, side, side. Okay, so that's what you're given. 3 sides, you're not told a dang thing about the angles. When you have that situation, it's much easier to use this manipulated version of the law of cosines. It makes it simpler to start by finding an angle. So the rule of thumb here is to start with the largest side. The largest side between 11, 10, and 17 is 17. So if you grab this 17 and look for its opposite angle, that is A. So we want to start by finding A first. The reason for this is when you do the law of sines next, you don't come up with the wrong angle. For example, the inverse sine of 1/2 could be 30 degrees. It also could be, the inverse sine of 1/2 could be 60 degrees. It also could be 120. So if you start with the largest side, you know that you have to get the largest angle because that's how geometry works. So let's try this thing. So let me grab my eraser and then clean up some of my scribbles here, and we'll get right to it. Okay, so we're going to start by trying to find angle A, which is across from the longest side, and that angle is unknown. So we have cosine of A equals, now we've got B and C, so we'll put those in. Remember that little b is the side across from angle B, which is here, and little c is across from angle C, which is here. And across from capital A is small side A, which is the 17 kilometers. So now we're ready to boogie. B is 10, so that's 10 squared, plus C is 11, so that's 11 squared, minus A squared, which is 17 squared. Okay? Now, I'm going to pause just for one quick second and show you one other thing here that you might find useful. How do you know which one is B, C, and A? Well, here's the deal. We're trying to find angle A right here, right? That is our immediate goal. Let me switch colors real quick. We're trying to find angle A, which is this guy. So you notice the first two numbers squared here, B and C, they flank angle A. They're the adjacent sides to angle A. And the one that you subtract at the end, you're subtracting this A squared. That's the one that is not adjacent, but it's opposite. So it's, you want an angle, which was A, then you square the two adjacent sides and you subtract the one that's opposite from the angle A you started with. That's kind of how I remember the formula. And then you divide by 2 times B and C, which are those adjacent sides, the 11 and the 10. So that would be times 10 times 11. Okay, it's all laid out in the picture for you where these values are coming from. So the next thing I would suggest to do is the following. Copy down your cosine A and just pop the numerator, the top of the fraction, into your calculator. So that would be 10 squared plus 11 squared minus the 17 squared, which gives you negative 68. Over, now I'm going to do the denominator, which would be 2 times 10 times 11. That gives you 220. So now I'm going to write down, actually, I'm going to get right into this. I'm going to do the inverse cosine because I just want angle A. So that's going to be the inverse cosine or second cosine of negative 68 over 220. So in my calculator, I'm going to press second cosine, and I'm going to press negative 68 divided by 220, enter, and I get 108, which is that big angle I was looking for, 108 degrees. Okay, so now angle A is established. Let me clean up my picture a little bit. So let me put in angle A. Its measure is 108 degrees. That's an obtuse angle. A triangle can only have one obtuse angle. So we know this is looking encouraging because now we have the biggest angle assuredly across from the largest side. So that's cool. So now what do we do? Well, very similarly to the last problem, now we have a side opposite angle pair established. So now we can roll into the law of sines and we can find an additional angle. So we can do A, which is 17, compares to the sine of its opposite angle, which is the 108. And now, I don't know, how about let's do C here. C is 11 over the sine of its opposite angle, which is capital angle C, which is unknown. Cross multiply, so we have this way, we have, actually no, we'll go in the direction of sine C. So 17 times sine C is this cross product, and now we have 11 times sine 108 is the other cross product. We want C by itself, which is attached to the sine function, so we're going to divide by 17 on both sides. These cancel. So we have sine C equals. Now what I'm going to do, ladies and gentlemen, is I'm going to take this entire expression and get a decimal equivalent for it. So I'm going to press 11 times sine 108, enter, divided by 17. We're going to get 0.6154 rounded. So now to get C by itself, you might know where this is going. You have to take the inverse sine, which is second sine of 0.6154. Remember, the inverse trig functions give us an angle. So now angle C is worth, I'm pressing second sine 0.6154, and we get 37.98, which is going to round to 38 degrees. Okay, so that is looking sweet. I'm going to pop that into our visual picture here. Let's see. That was angle C. Angle C is 38 degrees. So now the only thing that's missing is angle B. So we use the triangle sum of 180 minus the 108 that we know, minus the 38 that we know, and that will equal what? Arithmetic time. 180 minus 108 minus 38. Yeehaw! You get 34 degrees. And I like to always do a reality check before I move on. Do we know all three angles? Yep. Check, check, check. Do we know all three side lengths? 17 kilometers, 11, and 10. Booyah! All right, that's it. So by doing law of cosines followed by law of sines, we can figure out all the measures of a triangle, 3 angles and 3 sides. That's it. If you need to review this, feel free. And now it's your turn to try a couple at your leisure. Good luck and have a great day.